friends, so today we are gonna learn a new concept where we'll find out the analytic function when u plus v or u minus v is given. So how to get that value of analytic function when u plus v or u minus v is given? So for that I'll start with the analytic function. So let's consider the analytic function f of z over here, which is u of x comma y plus I v of x comma y, where u is the real part and v is the imaginary part. Now let's say there are certain cases in numerical where u plus v or u minus v is given to you, that is the combination of real and imaginary part is given to you, and we want to get the value of analytic function. So for that what we'll do is we will use one approach. So let's start with step number 1. So since f of z is u of x comma y plus I v of x comma y, we will reconsider this f of z as u plus iv. Now since the value of u plus v or u minus v is given in the numerical, since the value of u plus v or u minus v is given in the numerical, I should bring this f of z in such a format where u plus v or u minus v term will come in picture. Now here I have u plus iv, it means I don't have u plus v or u minus v. Now see how I am bringing it. So for that I will multiply this f of z or this equation f of z equal to u plus iv with I. So here we will get I into f of z is equal to I u minus v, because I square is minus 1. After that we are going to add these two functions, that is f of z and I f of z. So by adding it we will get f of z into 1 plus I is equal to, by adding the right hand side we will get u is the real part, let's add the real part with real part, so minus v, and here by taking imaginary I common we will get v plus u. So if I rewrite this, then here we got the value of 1 plus I f of z as u minus v plus I u plus v, and now we got the term u minus v as well as u plus v in the f of z. Now in the question, if u minus v is given, it means the real part is given, and if u plus v is given, then we will say that imaginary part is given, and from that we will get the value of analytic function. So let's see how to proceed. So in step number 2 we are going to consider this u minus v is capital U since it is the real part, and we are going to consider this u plus v as capital V because it is the imaginary part. Now as I said that when u minus v is given, that means the real part is given, that is capital U is given. So that time what we'll do? So since u is given, we are going to find out dou u, that is capital U by dou x, and the value of dou u by dou y. Then we are going to use the property of analytic function, that is the property is, that is the value of derivative of analytic function is given by the formula dou u by dou x minus I dou u by dou y. So by that property I can say 1 plus I f dash of z, that is the derivative, is dou u by dou x minus I dou u by dou y, and the value of dou u by dou x and dou u by dou y we will get from step number 3. Next, once we get the value of f dash of z, we are gonna apply the Milne-Thompson method, and by Milne-Thompson method we are gonna convert this f dash of z in terms of z, and then once we get the value of f dash of z in terms of z, we will integrate both sides to get the value of f of z. So here I will say after this step number 5 is Milne-Thompson's method. So by Milne-Thompson's method we will put x equal to z and y equal to 0 in f dash of z, and by this we will get f dash of z in terms of z, and in the last step we will integrate both sides, or I will say integrating f dash of z with respect to z, we will get the value of f of z. So by this method we are going to find out the analytic function f of z when u minus v is given. Now let's say friend, if u plus v is given, what will do? So this first step will remain same. Now since u plus v is given, it means the imaginary part capital V is given. So since capital V is given, I am going to find out the derivative which are related with v. So here I will write down in different color. So that time in step number 3 we are going to find out dou v by dou x and dou v by dou y. So this v is capital. Next we will change this formula of f dash of z. So we also have one formula of f dash of z, that is dou v by dou y plus I dou v by dou x. So by using this formula we are going to find out the value of f dash of z, that is the derivative of this analytic function f of z. And once we get the value of f dash of z, then the remaining two steps are same. That is, we are going to apply the Milne-Thompson's method, where we are going to put x equal to z and y equal to 0 in f dash of z to get the value of f dash of z in terms of z, and in the end we will integrate this f dash of z with respect to z to get f of z. So this is the method by which we can get the value of analytic function when u plus v or u minus v is given. Now we are going to use this method in one numerical. So the numerical is, we have to find out the analytic function f of z u, which is equal to u plus iv, such that u minus v is given and the condition, that is f of pi by 2, is given as 0. So now guys, since u minus v is given, you can see here that the real term or real part is given. So let's start. So we'll write down the step number 1 first. So here I will say, let f of z is equal to u plus iv, therefore I f of z is equal to I u minus v. Therefore by adding these two equations we will get I plus 1 into f of z is equal to u minus v plus I u plus v. Next we will say this as capital U plus I capital V, where capital U is equal to u minus v and this capital V is equal to u plus v. Now since u minus v, that is capital U, is given, so here I will say therefore the value of capital U is equal to cos x plus sin x minus e raised to minus y whole upon 2 cos x minus e raised to y minus e raised to minus y. Now guys, let's see the step number 2. So since u is given, we'll find out dou u by dou x and dou u by dou y. So for that I'll differentiate this u with respect to x and y partially. So by differentiating u with respect to x, we will get dou u by dou x as this denominator will be 2 cos x minus e raised to y minus e raised to minus y the whole square. So I am applying the u by v rule. Here we will get v, that is 2 cos x minus e raised to y minus e raised to minus y into derivative of this numerator. So derivative of sin x is cos x and derivative of cos x is minus sin x. So minus sin x plus cos x, derivative of e raised to minus y 0 since I am differentiating with respect to x. Next middle sign negative, this cos x plus sin x minus e raised to minus y as it is, and the derivative of this denominator is minus 2 sin x. So we got the value of dou u by dou x. Now let's find out dou u by dou y. For that I'll differentiate this u with respect to y, and y is there in numerator as well as in denominator. So again we'll apply the u by v rule. So therefore dou u by dou y is equal to, here we will get this term square in the denominator. So here I will write it down. It is 2 cos x minus e raised to y minus e raised to minus y the whole square. In the numerator we will get v into derivative of u. So 2 cos x minus e raised to y minus e raised to minus y, and the derivative of this numerator, here derivative of cos x is 0, sin x is 0, because we are differentiating with respect to y partially, and here we will get positive e raised to minus y. So e raised to minus y minus, now numerator as it is, so I will write it down, that is cos x plus sin x minus e raised to minus y into derivative of denominator. So this will be 0, here we will get minus e raised to y, and here we will get plus e raised to minus y. So minus e raised to y plus e raised to minus y. So we got the value of dou u by dou x and dou u by dou y. So now we'll move to step number 4, where we will substitute these values in the formula of derivative. So here we will get 1 plus I f dash of z is equal to dou u by dou x minus I dou u by dou y. So here I will say, therefore 1 plus I f dash of z is equal to dou u by dou x minus I dou u by dou y. So here we can copy both the values, dou u by dou y over here and dou u by dou x value here. Then we are going to apply the Milne-Thompson's method on this f dash of z, where we are going to substitute x as z, or we will replace x by z and y by 0. So we'll do it here itself. So here I will say, therefore by Milne-Thompson's method, put x equal to z and y equal to 0 in f dash of z. So here we will get 1 plus I f dash of z is equal to, now the value of dou u by dou x we have is this. So in this we will substitute x as z. So here we will get 2 cos z, y as 0. So e raised to 0 1, e raised to 0 1. So this will become minus 2. So here I will say it is 2 cos z minus 2. Next we will get here minus sin z plus cos z, or I would say cos z minus of sin z. Here again cos z plus sin z minus 1, and this term is also multiplying, so this minus and minus will become plus. So here I will write down plus 2 sin z, that is this term, into the bracket, that is cos z plus sin z minus 1. Here I will write it down in the bracket, cos z plus sin z minus 1 upon, here 2 cos z, e raised to 0 1, this is 1, so 2 cos z minus 2 the whole square, 2 cos of z minus 2 the whole square. So this is the value of dou u by dou x at x equal to z and y equal to 0 by Milne-Thompson's method. Now let's find out value of dou u by dou y at x equal to z and y equal to 0. So here I'll write minus I into dou u by dou y. So I'll write it down in the bracket. So this is the first bracket of dou u by dou x. Now dou u by dou y is like this. Here we will get 2 cos z minus 1 minus 1. So 2 cos of z minus 2 in the bracket, e raised to 0 again 1. Here we will get e raised to 0 1, e raised to 0 1, but this is negative 1, so positive 1 negative 1 0, so second term will be 0. So here I will say minus 0 upon, here we will get 2 cos of z minus 2 the bracket square. Now here in the second term we can cancel this bracket, because here we are going to get 2 cos z minus 2 in numerator. So we will cancel it, one bracket with this square term. So we will get 1 upon 2 cos z minus 2 in the second term. Here we will multiply these terms. So we will get, therefore 1 plus I f dash of z equal to, so first of all I will multiply this 2 cos z minus 2 term with cos z. So this will be cos z into this 2 cos square z minus 2 cos z, 2 cos square z minus 2 cos z. Next we will multiply this bracket with minus sin z. So here we will get minus 2 sin z cos z plus 2 sin z. After that we will multiply this second bracket with 2 sin z. So 2 sin z into cos z, that is plus 2 sin z cos of z. Here 2 sin z into sin z, that is plus 2 sin square z, and the last term will be minus 2 sin z upon 2 cos z minus 2 the whole square. So 2 cos of z minus 2 the whole square. Next, so this is the numerator. Next the second term is minus I upon 2 cos z minus 2. I will write it here, minus I upon 2 cos of z minus 2. Next here we will get 1 plus I into f dash of z equal to, so if you will see here, then this negative 2 sin z cos z will be cancelled with positive 2 sin z cos z. Next minus 2 sin z will be cancelled with positive 2 sin z, and here we will get 2 cos square z plus 2 sin square z. We can take 2 common and we will get cos square z plus sin square z 1. So 1 into 2, that is 2, and minus 2 cos z as it is upon 2 cos of z minus 2 the whole square minus I upon 2 cos of z minus 2. Now what I will do is I will take LCM, and that is 2 times cos of z minus 2 the whole square. So here we will get 2 common, so 1 minus cos of z, and here we will multiply this denominator and numerator with 2 cos of z minus 2. So here we will get minus I into 2 cos of z minus 2. Next 1 plus I f dash of z equal to, now from this numerator we can cancel this minus 2 sin z with positive 2 sin z. Next 2 sin z cos z with negative 2 sin z cos z. Here minus 2 cos z as it is, and from this 2 term we can take 2 common, and cos square z plus sin square z will become 1. So here we will get 2 minus 2 cos of z upon denominator is 2 cos z minus 2 the whole square minus I upon 2 cos of z minus 2. Now from the first term what we can do is I will take negative sign outside, so we will get 2 cos of z minus 2 in the bracket, because in the denominator we have the same term and we can cancel it. So now we got minus 1 upon 2 cos z minus 2 and minus I upon 2 cos z minus 2. So I can take 1 upon 2 cos z minus 2 common, and in bracket we will get minus 1 minus I. Now if we will simplify this, then we will get 1 upon 2 common cos of z minus 1 and minus 1 minus I as it is. Now what I will do is, I will take negative sign outside from here, so that it will become 1 minus cos z, and then we can apply the formula of trigonometry. So when this negative sign will come out, this will become 1 minus cos z in bracket, and negative sign from numerator will come out, and here we will get 1 plus I, and that negative sign of numerator and denominator will be cancelled. So we will get 1 plus I in the numerator. So here we will get 1 plus I in the numerator and 2 into 1 minus cos of z. So this is equal to, now left hand side is 1 plus I into f dash of z. Now what we can do is, we can cancel this 1 plus I from both sides. So we will get f dash of z as 1 upon 2 as it is. 1 minus cos of z is 2 sin square z upon 2. So this will become 1 by 4, and 1 upon sin square is cosec square of z upon 2. So this is the value of f dash of z. Now let's find out the value of f of z from f dash of z, and for that we will integrate both sides with respect to z. So here I will say integrating both sides with respect to z. So we will get f of z equal to 1 by 4, and now we will find out the integration of cosec square z by 2 term, that is minus cot of z by 2 upon 1 by 2 plus c. So here 2 ones are 2, 2 twos are 4. So I will say it is minus 1 by 2 cot of z by 2 plus c is the value of f of z. Now if you will see the question, then here we have to find out the value of analytic function f of z. Also the condition f of pi by 2 equal to 0 is given. Now why it is given? So if we will put this value pi by 2 at z, then we will get this constant c. So we have to find out the value of f of z in such a way that we should eliminate this c, or we should get the value of that constant c. And for that, now I will put z as pi by 2 in this equation. So here I will say, therefore put z equal to pi by 2 in f of z. So we will get f of pi by 2 equal to minus 1 by 2 cot of pi by 4 plus c. Now here we have z by 2, so z is pi by 2 upon 2 will become pi by 4. Now the value of f of pi by 2 is given as 0 in question. This is minus 1 by 2, and the value of cot of pi by 4 is also 1 plus c. So from here we get the value of c as positive half. Now we will put this value of c in f of z again. So we will get f of z as minus half cot z by 2 plus half. So therefore f of z is equal to minus 1 by 2 cot of z by 2 plus 1 by 2, and if we will take 1 by 2 common, then in bracket we will get 1 minus cot of z by 2. So this is the value of f of z. Thank you.